Good day everyone, I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about radicals and writing expression with rational exponent as radicals, vice versa. Now let's define first what are radicals. So the symbol nth root of a raised to m is called radical. A radical expression or a radical is an expression containing nth root of a raised to m, where your square root there is the radical sign, the n there is the index or the order, and a raised to m there is the radicand. The index or order, which indicates the degree of the radicals, such as square root, example square root of 9, cube root, example cube root of 27, and fourth root, example fourth root of 16. The radicand, which is a number or an expression inside the radical sign, this one, or the radical symbol, and m is the power or the exponent of the radicand. If m over n is a rational number and a is a positive real number, then a raised to m over n is equal to nth root of a raised to m, or equal to nth root of a raised to m, provided that nth root of a raised to m is a real number. The form nth root of a raised to m is equals to a raised to m over n is called the principal nth root of a raised to m. Through this, we can write expression with rational exponent as radicals. So for example, here we have 12 raised to 1/3. 12 is the base, 1/3 is the exponent. And then we have here the nth root of a raised to m, that is the radical sign and is the index, and a raised to m is the radicand. So now we have example here in changing exponential expression to radical expression. So we have here 5 raised to 2/3 here. The 5 here now is the base of the radicand, and the numerator, the 2, is the exponent of the radicand, and the denominator now is the index of the radical. So now the 5 raised to 2/3 is equals to cube root of 5 raised to 2. Or we can say as cube root of 5 raised to 2. Another examples, we have 7 raised to 1/2. So the 7 now is the base. The numerator 1 is the exponent of the radicand, and the denominator is the index now. So we have square root of 7 raised to 1 or square root of 7. Another example here, we have 3a raised to 2/3. So we have here 3a is the radicand here, and the numerator 2 is the exponent of the radicand, and the denominator now is the index. So we have cube root of 3a raised to 2. To simplify, you need to distribute the exponent 2. So we have cube root of 3 raised to 2a raised to 2 equals to cube root of 9a raised to 2. Another example, we have 4z raised to 2/5. So since z here is the only have the exponential or the exponent as the fraction exponent or exponential expression, and 4 here is still a whole number, so you just need to copy 4 and then change z raised to 2/5 into radical expression. Z is the base here, the 2 is the exponent, z raised to 2, and the index here is the denominator, or 5. So we have 4 fifth root of z squared. So note, we need to impose that the condition a is greater than 0 in the definition nth root of a raised to m. For an even n, because it will not hold true if your a is less than 0. If a is a negative real number and n is an even positive integer, then a has no real nth root. Now we need to take note of that. If our radicand here is less than or negative real number, and the n or the index is a positive integer, that means there has no real root in that given radicand. If a is a positive or negative real number and n is an odd positive integer, what is an odd positive integer? 1, 3, 5, 7, 9, and so on. Then there is exactly one real root. So there is a real root of that, of the a. The sign of the root being the same as the sign of the number. So we have here an example. We have a square root of negative 8. The a here, or the radicand, is negative real number, and the index is 2. That is an even positive integer. That means there is no real root. Again, we need to take note, if your a is a negative real number and your index or your n is a positive, even positive integer, that means there is no real root. Another example, we have fourth root of square root of 3 fourth root of negative 32. Fourth root of negative 32. Again, we need to satisfy the condition. The radicand is negative real number and the index here is an even positive integer. That means diretso dayon, no real root. In this example, negative 8. So we have cube root of negative 8. So we have here, a negative real number and the index is an odd positive integer. So we need to take note of this one. Then there is exactly one real root. Okay, so what is the cube root of negative 8? We have negative 2. There is an answer for that one. So another example, we have fifth root of negative 32. So the radicand here is a negative real number and the index is a odd positive integer. That means there is a solution for this one. That is negative 2, the answer for that one. Now we need to writing expression in rational exponents as radicals, vice versa. Write each of the following radical form, express it to simplified form. So we have here number 1, z raised to 4 over 7. So the index here, again, the index is the denominator and the base of the radicand is z, and then the exponent is the numerator. So we have here 7th root of z raised to 4 or 7th root of z raised to 4. So we have here number 2 example, 75 raised to 1 over 6. 75 is the radicand and the exponent of the radicand is 1. The index is 6. So we have 6th root of 75. So next we have 15 x raised to 2/5. So since the x variable is the only raised by the exponent here, so copy 15. So you will get 5th root of x squared or 15 and 5th root of x raised to 2. Next, we have n o raised to 1/2. Again, in this example, o here is the is with exponent here. So you just need to copy n and then change the o raised to 1/2 to radical form. So we have in n and square root of o, or n squared of o. Another example, we have here number 5, x plus 7, x plus y raised to 7 over 9. So again, the x plus y is the radicand and then the exponent for that one is 7, the numerator. The denominator 9 is the index. So we have here 9th root of x plus y raised to 7 or 9th root of x plus y raised to 7. Next, we have 3m raised to 4 and raised to 2/3. So in this one here, the base of the radicand is 3m raised to 4n. The exponent of the radicand is 2, the numerator, and the denominator is the index. So we have here cube root of 3m raised to 4n raised to 2. And then you distribute the exponent here. So we have 3 squared, m raised to 4 times 2, n squared. So to simplify that one, we have cube root of 9, m raised to 8, n raised to 2. Next example, we have 2m n raised to 2/5. 2mn now is the base of the radicand, the exponent of the radicand is 2, the numerator, and the index here is the denominator 5. So we have here fifth root of 2mn raised to 2. Simplify the exponent here, the expression here. So we have 4, fifth root of 4m squared n squared. And then next we have 16 n raised to 3. So 16 is the base and then the exponent is 2. The index is 3. So we have cube root of 16 raised to 2. So simplify 16 raised to 2. We have 256. That is cube root of 256. To simplify cube root of 256, we can write this one as 256 is equals to 64 times 4 to factor the radicand. So 64 now is, we can simplify that one into 4 raised to 3. That is 4 times 4 times 4, we have 63. Times 4, you will get 256. It's the same. So since we factor this one, so since 4 raised to 3 now can be simplified, cube root of 4 raised to 3, we can take that out. So we have here 4, the remain value in the radical now is cube root of 4. So the final answer is 4 cube root of 4. So write each of the following into rational form. So here from radical form to rational form now. So example number 1, you have cube root of 10 raised to 4. So we need to take note that the index 3 here is the denominator of the rational form. And then the power of 4 is the numerator and the 10 here is the base. So we have here 10 raised to 4/3. Example number 2, we have 6th root of 55 raised to 4. The index or the denominator is 6. The exponent is the numerator and the base is 55. So we have 55 raised to 4 over 6. You can simplify the exponent by reduce that one. So 55 raised to 2/3. Example number 3, we have square root of 28 raised to 7. So we need to change that one into a rational form. The denominator is 2. The index, the exponent is the numerator, and the base is 28. So we have 28 raised to 7 over 2. Next, fourth root of a plus 2. So the base is a plus 2. The denominator of the exponent is the index 4. And then the numerator of the exponent is 1. Since we have here, it is raised to 1. So a plus 2 raised to 1/4. Next, we have cube root of 3z raised to 2. So we have 3z raised to 2/3. Example number 5, we have square root of 2xy raised to 3. So we have here 2xy raised to 3 over 2. So we have here the numerator is the exponent, the base is 2xy, and the index, since it is we already know na if there is no value in the square root, that means the index is 2. Okay, so since that's why we have 2xy 3 raised to 3/2. 7, we have 2 and fourth root of p. So copy 2 here, and then p will be raised to 1/4. Example number 8, we have cube root of a squared plus b cubed c raised to 4 raised to 2. So all of them, the base here is a squared b cubed c raised to 4, and then the numerator is 2. The exponent and the index will be the denominator. So we need to simplify this one, distribute the exponent 2/3 in each variable. So we have a raised to 2 times 2/3, b raised to 3 times 2/3, and c raised to 4 times 2/3. So now we have a raised to 4/3, b raised to 6/3, and c raised to 8/3. So simplify if some of the variable can be simplified. So we have a raised to 4/3, b raised to 2, and c raised 8 over 3. So that's the final answer. Again, thank you so much for watching. I hope that you've learned something out of the lesson. Please don't forget to like, subscribe, and if you have question, you can comment down and share it with your friends. Thank you so much, and God bless everyone. Goodbye.